Good morning, respected judges. I am Abhay from SVM Himrashmi Parisar, Vikasnagar, Shimla. I am presenting a project with two parts under one common vision: new innovations related to defense. My first project is PRAHARI, a hybrid surveillance system. But before I show how it works, let me take you back to an incident from India's past. In 1965, a sensitive monitoring device was taken to Nanda Devi to monitor activity across the border. But extreme weather forced the team to leave it behind, and the equipment was eventually lost on the mountain. That makes me think of a question. What if technology could keep watching even when humans cannot? That is the idea behind Prahari. Prahari uses an ESP32, BH1750, C4001 ultrasonic sensor, a servo, and a camera with YOLO-based remote detection. But there is an important part of my design: power efficiency. In remote and hilly areas, continuously running a radar can consume significant power. So instead of keeping everything active all the time, Prahari has a watch mode. Let's see. So now I'm gonna show you the demo of my system Prahari. So right now it is under watch mode and only two sensors are active: BH1750 and C4001. They both are passive sensors and consume very little power. So I got a friend of mine to help me out for AI detection. So now we are gonna see the demo. So this is the hardware part of Project Prahari. These two are the passive sensors. One is BH1750 and other is C4001, and they consume a very little power. So let's move on for the AI detection. I got a friend of mine who will help with this. As you can see, when he came in front of the camera, the AI detected him and showed a pop-up. Now, the operator who was sitting in front of the computer or laptop, he could manually start the radar, or as if he thinks that the AI had made a mistake, then he can stop the radar or not even start it. So let's see by starting the radar. So it gives the pop-up alert again. Now you can see all the readings here. So the main thing that this hardware does is that it first starts the passive sensors as they consume very little power, and when a human is detected, you can manually start the radar for better readings, and then the radar starts as it consumes more power. Therefore, it is separated from the main system and comes under the track mode. So rather than continuously consuming power with every system active, Prahari use intelligent layered surveillance. Monitor first, active when required. And in the future, I want to expand the YOLO detection system to identify drones, aircraft, and other relevant objects while improving range and accuracy. But detection is only half of defense, because once information is detected, it needs to reach somewhere. That brings me to Photon X. Instead of depending on conventional radio communication, Photon X explores free space optical communication using light to carry information. It uses an ESP32S3 laser transmitter, BPW34 photodiode, and NM358 amplifier to transmit and receive digital information. Now let's see its working. So this is my project photo. This is the TX side and this is the RX side. Now we are going to communicate over laser, and I'm going to show you a demo for that. So now let's start the receiver side. As you can see right now, here is nothing on the receiver side. Now I'm going to start my TX side. As you can see, our receiver had catch the information that was conveyed by the laser, and then it decoded it and showed on the OLED. So the main purpose of this project is I enter the information here. The ESP converts it into digital signals. The laser transmits those signals through line, and at receiver, the BPW34
detects the light, the LM358 amplifier amplifies it, and the ESP32 reconstructs the data.
With further support, I want to improve Photon X for longer range, greater reliability, and higher data rates. Because I don't want these to remain competition prototypes, I want them to become solutions. Prahari watches, Photon X communicates. And my vision is simply don't wait for the future to demand better technology. Build it before the future exists. Thank you.